Welcome to the deep dive. Today we're jumping into the pretty incredible science of our brains, how they learn, how they adapt.
And how that understanding is really shifting things.
Totally. You've probably heard some common ideas, right? Like the brain sort of sets in stone after childhood, or we only use like 10% of it.
Yeah, those old chestnuts.
Well, get ready because most of that isn't quite right.
Not at all.
Mhm.
What's truly, I think, revolutionary is just how much we now understand about the brain's flexibility, its plasticity.
Huh?
With new imaging, we can almost, watch it happening. It's this dynamic organ, constantly changing in subtle but really profound ways.
And that brings us right to our main topic, neuroplasticity.
Mm-hmm.
This is the idea, and it's kind of mind-blowing, that every single time you learn something, anything, a tiny fact or some complex skill, you are physically changing your brain.
Hope that sink in.
Your brain is basically a work in progress,
All right.
always being shaped by what you do. It's, transformative.
It really is. The old view for so long was that, well, after your teens, any big brain changes were probably bad news. Decline, damage.
And like losing cells as you get older.
Exactly. But now we know the adult brain keeps reorganizing, rewiring itself.
Yeah.
It doesn't just stop.
Which is just incredibly hopeful, isn't it? Especially when you think about recovery from, say, a stroke.
Oh, absolutely. That ability to regain function often comes down to exactly this, the brain finding new paths, that neural reorganization.
So our mission today for this deep dive is to get into the nuts and bolts of this neuroplasticity. How does the brain actually reshape itself when we learn? And, what does this mean for all of us?
Let's dive in.
Okay, so this amazing adaptability, how does it work? Like on a basic level, I understand there are sort of three main ways the brain changes. The first one involves chemicals.
That's right.
Ugh.
At its core, the brain runs on chemical signals passed between billions of neurons. These tiny connections, that's where everything happens. So when you're learning, the brain can quickly boost these signals, maybe release more chemical messengers or make the connections more sensitive to them.
Ah.
This happens fast, and it seems to be what supports short-term memory, that feeling you get when you're practicing something and you suddenly kind of get it.
Right, like learning a little guitar riff or something and your fingers just start doing it correctly. For that moment, you feel like, okay, I've got this.
Exactly that feeling. But that's often temporary, relying on those chemical boosts.
Okay, so what's the second way then? You said it's more profound.
Yes, the second involves actual structural changes. The physical wiring between neurons gets altered. Think of it like the brain literally rebuilding parts of its own circuitry.
Whoa, so not just a quick chemical message boost, but like building new roads or strengthening existing ones, making actual lasting connections.
Precisely. These structural changes, they take more time. They need sustained effort. This is what underlies long-term memory and that really deep, lasting skill improvement.
Okay, so that explains why the guitar riff I nailed yesterday feels completely alien today. The chemical boost faded, but the structural changes haven't, locked in yet.
You got it. If that underlying structure hasn't changed enough, the skill can seem to vanish overnight. It's why practice, consistent practice, is so key.
That makes so much sense. It explains those frustrating learning plateaus perfectly. So these structural changes,
Yeah.
do we have real evidence? Like, can we see this rewiring?
Oh, absolutely. There's compelling evidence. For instance, people who read Braille fluently. Studies show the brain area processing their fingertips is physically larger than insighted people.
Wow.
Or, the part of your brain controlling your dominant hand is usually a bit more developed. And maybe the classic example is the London taxi drivers.
Ah, yes, I've heard about this.
To get their license, they have to memorize this incredibly complex map of London streets. And research found they tend to have a larger hippocampus that's a key area for spatial memory.
So these aren't just like functional differences in how they use their brain, but actual measurable physical differences in size linked directly to the skill.
Exactly. The brain physically adapts to the demands placed on it.
Okay, those are great examples. So chemical changes for the short term, structural rewiring for the long haul. What's the third part of this neuroplasticity puzzle?
The third is functional change. This is more about how efficiently brain regions operate and coordinate. When you use a specific brain area a lot, it tends to become more easily activated, more excitable, you could say.
Like it gets better at its job with practice.
Sort of, yes. And over time, this increased efficiency can lead to shifts in how different brain areas work together in networks. The brain fine-tunes its operations, maybe shifting responsibilities slightly to optimize performance for that task.
So it's not just connections strengthening one-on-one, but whole regions becoming maybe more specialized or efficient within the bigger picture, like a team getting better coordinated.
That's a good way to put it. And it's really important to remember these three things: chemical, structural, functional, but they don't usually happen in isolation.
Fair.
They often work together across different parts of the brain to support learning. It's a coordinated effort, though one type might dominate at different stages of learning.
Okay, this paints a picture of an incredibly dynamic, adaptable brain, but here's the question that always comes up. If our brains are so plastic, why isn't learning always easy? Why do we forget things? Why do some kids struggle so much in school? And like you mentioned, why is recovering from something like a stroke so hard sometimes? What holds this plasticity back?
That is the critical question, really, and it's where a lot of the research is focused. The
Yeah,
challenges in stroke recovery really threw these limitations into sharp relief.
you're right.
I mean, medicine's gotten much better at helping people survive strokes, but restoring lost function effectively, that's still a huge hurdle. Stroke remains a leading cause of long-term disability, and honestly, our rehab methods haven't kept pace as much as we'd hoped.
So even with this built-in ability to rewire, the brain doesn't just snap back after major damage. Why the difficulty? What's missing?
Well, one really fundamental thing we've learned is that behavior is the key driver,
Behavior, meaning.
meaning what you do, active engagement. There isn't, a neuroplasticity pill you can take to just fix things or learn instantly. Not yet, anyway.
Right, no magic bullet.
No. The most powerful way to drive these positive brain changes is through practice. Targeted, consistent practice. You actually have to do the work.
Okay.
And interestingly, some research even suggests that the level of effort, even the struggle involved in the practice, might be crucial. More effort, more struggle, can actually lead to more learning and bigger structural changes. The brain seems to respond most when it's really challenged.
So just passively listening or watching isn't enough. It's that active, deliberate effort, maybe even feeling difficult, that really kicks the process into gear.
It seems so, yes.
That makes a lot of intuitive sense. But you also hinted earlier that neuroplasticity isn't always good. It can have downsides.
That's a really crucial point. We
Oh.
tend to focus on learning new skills, but plasticity is just the brain adapting to experience,
Mm.
period. So that means it can also underlie things we don't want, like forgetting information we once knew, or the development of addiction, that's the brain adapting pathologically to drug use,
Mm.
or even chronic pain, where pain pathways become hypersensitive.
No.
The brain is constantly being shaped, molded by what we do and what we don't do. Our habits, our experiences, they sculpt it, for better or worse.
That is a really powerful thought, almost a bit scary. This amazing adaptable tool can be shaped negatively by our patterns, too. Okay, shifting slightly, you mentioned earlier that learning isn't one size fits all, and that kind of pushes back against things like the 10,000-hour rule.
Right, that idea that just putting in 10,000 hours guarantees you'll become an expert. It's catchy and it highlights dedication, which is important, but it massively oversimplifies things.
How-
Because our brains are just so incredibly individual. Their structure, their function, how they respond to different kinds of practice.
Mm.
It varies hugely from person to person. What works wonders for one person might barely make a dent for another, even if they're learning the same thing.
So this sounds like it ties into that idea of personalized approaches, maybe like personalized medicine.
Yeah.
I know in cancer treatment, they look at individual genetics.
Exactly. That's a great analogy. In oncology, they can look at genetic markers in a tumor to pick the best treatment for that patient.
Mm.
We're trying to do something similar in neuroscience. Can we find individual characteristics of brain structure or function, we call them biomarkers, that could help us tailor learning strategies or rehab programs?
So instead of just a generic approach, you'd use these brain biomarkers to figure out the best way to teach someone or help them recover after a stroke, make it more targeted and effective for them.
That's the goal. And the research so far suggests it's probably not just one biomarker, but likely a combination of different brain measures that will give us the best predictions about how someone's brain might change or how well they might recover. The brain's just too complex for one single marker to tell the whole story.
Makes sense.
But the key thing is, what we learned from studying stroke recovery or specific skill learning, these fundamental principles of neuroplasticity, they apply to everyone, all the time.
What do you mean?
Our everyday lives, our habits, the things we choose to focus on or ignore, they're constantly subtly shaping our brains. It's not just about big learning events or recovery from injury.
So this connects back to why some kids might thrive in one type of classroom setting and others struggle, or why learning a language feels almost natural for one person.
And like climbing a mountain for someone else.
Right, or why some people just seem to pick up sports easily. It's all tied back to our unique brain wiring and how it responds differently.
Exactly. And it means that, just by listening to this, by engaging with these ideas today, your brain is actually different now than it was an hour ago.
Huh, that's quite a thought.
It's the reality of neuroplasticity, this constant individual process of change.
It really is profound when you think about it that way. So, figuring out these unique patterns, how each of our brains changes differently in response to things, that's the key to future progress. In neuroscience, education, therapy.
That really is the core of it, I think. If we can get better at understanding individual neuroplastic patterns, we can develop much more precise, much more effective ways to help people learn, recover, and just generally thrive. It's about finding that better match learner to teacher, patient to therapy.
And the impact goes way beyond the lab or the clinic, doesn't it? This knowledge is relevant for all of us as, parents trying to help our kids.
As teachers in the classroom, managers building teams.
And just as individuals trying to keep learning throughout our lives.
Absolutely. It gives us a reason to pay more attention to ourselves, right?
Yeah.
How do you learn best? What kind of practice actually works for you? What feels effortful but ultimately productive? It encourages that kind of self-study.
So the message isn't just your brain can change. It's more like you are the sculptor, so pay attention. Be conscious of the habits that help your brain. Maybe work on breaking the ones that don't.
Exactly that. And crucially, remember the importance of actually doing the work, that active engagement we talked about. That's what drives the change.
And remembering that what works for learning one thing, say music.
Might be totally different from what works for learning something physical, like snowboarding, yeah. Even for the same person.
Right. Different skills might need different strategies.
Definitely. So maybe the thought to leave you with as you go about your day after hearing all this is to really internalize it.
Hmm.
Everything you do, every choice, every effort, it's shaping that incredibly plastic brain of yours, for better or for worse.
So the final nudge is
Go out there and, intentionally build the brain you want to have.